So in 1.10 here, we're going to be solving basic inequalities. Remember, an inequality is anything with a less than, greater than, less than or equal to, or greater than or equal to symbol in there. And before we even get to solving these, I want to just make sure that we are all caught up on inequalities versus interval notations versus what those graphs would look like. So if we're talking about inequality symbols, let's do less than or greater than. If I'm using the less than or greater than symbol, using interval notation, I want to use parentheses. And then the graph of that would use an open dot. If I'm looking at less than or equal to or greater than or equal to, I want to use brackets. And the graph is going to be a closed dot. All right. Now, when I'm talking about the parentheses and the brackets, it could be, one side maybe gets the parentheses and the other side gets the bracket, or maybe they both have brackets or they both have parentheses. It just depends on what your solution is. So let's do a few examples here. Let's say, I've got this first example, and let's say I have the inequality x is less than 3. Well, if I'm looking at x is less than 3, I see that I have the less than symbol, so I'm going to want to use a parenthesis and an open dot on the graph. So what that would look like is I'm going to go from, less than 3, I'm going to negative infinity, right? It's a parenthesis here because, again, we're not actually at the number 3. We're just strictly less than the 3, so it's going to be a parenthesis. And then, again, we can never get to negative infinity, so for infinity and negative infinity, I always use a parenthesis. And then my graph would look like this. We're going to have 3 right here. It's just less than 3, so it's an open dot, and less than 3 is to the left. So that would be anything over in this direction. So that would be the representations for x is less than 3. Let's say I have x is greater than 5, how about? Well, if x is bigger than 5, that means that it can go from 5 all the way up to positive infinity. Again, we're not actually including the 5, so it's a parenthesis, and we can never quite get to infinity, so it's also parenthesis. On my number line, we'd go ahead and we'd put 5, and it's anything bigger than 5. So again, I'm not including the 5, open dot, but it's going to be anything greater than to the right of 5. Let's say we had x is less than or equal to negative 2. So again, I'm looking for anything that's smaller than negative 2. So that could be anything from negative infinity up to negative 2. Now, I do want to include the negative 2 because it is less than or equal to. Again, I can never get to negative infinity, so we always put parentheses with infinity and negative infinity. How this would look on the number line is I would put negative 2. It's going to be a closed dot because it could equal to negative 2. And then it's anything smaller, which is going to be to the left over here. All right. And then the last possibility, x is greater than or equal to, I don't know, let's say 0. Well, if x is bigger than or equal to 0, we want to include 0 in my answer, and we're going all the way up to any value bigger than 0, right? So up to infinity. Again, we can never get to infinity, so we use a parenthesis, and we want to include the 0, so we use a bracket. And on my number line, we're going to have 0 right there. I want to include the 0, and we're going all the way up to positive infinity. And it'll look just like that. So some key things to think about here. Notice how infinity always has a parenthesis, right? Negative infinity as well. Parenthesis, 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 parenthesis. Parentheses mean that you're not including that value, that you can never actually get to that value. So like when I talk about x is less than 3, notice 3 is not a solution, right? It has to strictly be less than 3. So I don't want to actually include 3, hence the parentheses. Versus in this example here with the negative 2, x has to be less than or equal to negative 2. So negative 2 is a possible answer because it could equal to. Therefore, I want to include it, and I use the brackets for that. All right. One other thing to note, very, very important. When you use interval notation, notice how the smaller value is always on the left, and the larger value is always on the right. Negative infinity is smaller than 3. 5 is smaller than infinity. Negative infinity is smaller than negative 2. 0 is smaller than infinity. You always have to go from small on the left to large on the right. That's always the case. If I had, for example, I'll do this in red because it's incorrect. If I had written infinity comma 5, that would be incorrect, all right? Because 5 is larger than infinity, which is not okay. All right, so we don't want to do that. You always have to have it in the correct order from small to large. So let's go ahead and try an example. we're going to solve. How about we try 3x minus 8 is less than or equal to 16. All right, so we're going to go ahead and solve this. I'm going to start by adding 8 on both sides, just like you would a normal equation. These cancel, and now we end up with 3x is less than or equal to 24. We're going to go ahead and divide both sides by 3 to isolate the x. And we find out that our answer is x is less than or equal to 8. So in this case, we have the inequality, but I'm going to ask you to also write the interval notation for this. So interval notation, again, I'm looking for anything less than or equal to 8. So we know we could go from negative infinity all the way up to 8, and we could include that value 8. All right, so I want to put a bracket around the 8 because I'm including it. It's the or equal to right there. But I can never get to negative infinity, so always a parenthesis there. As for the number line, we're going to put 8 right on the number line. It's or equal to, greater than or less than or equal to, so I want to do a closed dot. And anything less than or equal to 8 is going to be off here towards negative infinity, this way over there. All right, so those would be the 3 different ways that you could write the solution. Let's try one more. All right, let's do negative 3x minus 1 all over 5 equals, let's make it a 4, all right? So we're gonna go ahead and I would start by multiplying both sides by 5 here. Times 5 times 5. We see that a 5 on top and bottom will cancel out with each other, leaving me with negative 3x. And you know what, my mistake here, I'm put an equal sign here. Let's make it just greater than. So change that to just greater than for me, all right? So now we got negative 3x minus 1 is greater than 20. And then we're going to go ahead and we're going to add 1 on both sides. And these will cancel on the left. Now we have negative 3x is greater than 21. Now remember, when I am working with inequalities, and if I ever divide by a negative, we are dividing by negative 3 here. Since I am dividing by negative 3, these cancel. So we just get x, but whenever you divide by a negative, you have to switch the sign. Notice how the greater than becomes less than. And 21 divided by negative 3 is negative 7. So this is my inequality. If I were to write that in interval notation, I'm looking for anything smaller than negative 7. So I could go from negative infinity up to negative 7, but we cannot include that negative 7 because it's just the less than symbol. If I'm thinking about a graph of this, we'd put negative 7 on the graph. And again, it's an open dot this time because it's just less than, and we are going to negative infinity off to the left. So that would be your graph there. All right. So if you just, big thing there is just don't forget whenever you multiply or divide by a negative, that means that you have to flip the sign.